Hey everyone, it's Mike, and today we're going to talk about SQL joins. In the last lesson, we talked about the different relationships between all the different tables and how a primary key can relate to a foreign key, giving us these one-to-many relationships. And today we're going to start to take advantage of that with the join operator. So let's get started by pulling up all of our orders. And when we pull up all of our orders, you can see that we have our customer ID sitting here, and we know that our customer ID corresponds to our customers table because of this relationship right here. And so what we can do is we can actually bring all of this information in and combine it with our orders table. And we know that many customers can have many orders. Before we join really quick, let's order by customer ID. And so you can see that customer 4, for example, starts to have 2 orders in the system, which is a totally normal thing. And so we're going to go ahead and join these two tables together. And when I join tables, I like to give my table name an alias. I'll show you why. And if we don't give an alias, we have to select all from orders, inner join from customers on, and we could try and say customer ID equals customer ID because that's what we're joining on, right? And if we try and run this, it's actually going to give us an error. It's going to tell us that there's an ambiguous column named customer ID, and it's because both tables, both the customer table and the order table, both have a column named customer ID, so it doesn't know which one I'm talking about. And so one way you solve that is you do orders dot and customers dot in front of the two, and then this SQL query will run because now it knows this is the customer ID from the orders table and this is the customer ID from the customers table, and it's able to join the two together. Now this could get a little long-handed now because I have to start referring to everything. So you'll often see people abbreviate these tables. I like to use the first letter of the table name until I start to get some conflicts, like when I'm doing customer and category in that place I'll maybe use 2 or pick a different letter. But you'll often see people start to shorthand tables with the aliases the same way we can rename columns. So when we run this select all, now we have the results from both tables combined. And we're still ordering by our customer ID, and so you can see customer 4, which name was around the horn, has 2 orders, order number 10355 and 10383. And so there's a lot of data going on right here. And so originally when we're studying the group by, we start to group by things. So I can actually group this by our customer name rather than grouping it by the ID, and we won't need this order by for now. And we can print out the customer name, and we can run our sum or count operator. We're going to count the number of orders, count order ID as num of orders. We can run this command. And before, when we were without the join, we had no idea who the customer name was. It looked something like grouped by the customer ID, and we would just see the number. But now we can actually start to put the customer name next to the number, so it becomes a lot more legible for people to read on reports. We can order this by num orders in descending order, and we can see that Ernst Handel is our best customer. And so that's kind of how joins work, and so I'll start to do a few more advanced joins here in just a second. So going back to, let's print out the 2 IDs. Let's print out our C dot customer ID and our O dot customer ID. We'll take away our group by, otherwise it won't know what those columns are. We'll take out our count. And I noticed in this version of SQL, for whatever reason, it knows these 2 columns are the same because they're being joined, so it drops it down to 1 column. On the versions of SQL I use, it doesn't do that. It normally would say you'd have 2 versions of customer ID, but we can put this is our cust ID, and this one is our order cust ID. And you can see that customer 90 is represented, and it's the same on both these tables. And that's what a join is doing. It's taking everything that's the same and it's putting all of that information together. And this is often represented in this diagram right here. Table 1 would be our customers table. Table 2 would be our orders table. And there may exist data in our customers who haven't placed an order. In this particular case, we wouldn't have an order that doesn't have a customer, and so really all of table 2 would be shaded in, and maybe we would see something like all these people have orders, and there wouldn't really be any order that didn't have a customer associated with it. So it's not a true diagram, but maybe you get the idea there. So the question becomes now, let's go back to who our best customer was. What is a left outer join and why is it useful? And so you can see here that we have 74 records that returned, and if we look in our customers table, we actually have 91 records. And so we know that we're missing a few of our customers because we only have 74. So we're missing, what, 17 of our customers, and it's because they never ordered. When this join happens, the data drops out, and that's why this left outer join is important. So if we change this to a left outer join and run the exact same command, oh, we need to flip our tables too. We need customers to be our first one. We would normally want a right outer join in this case, but again, this version of SQL is limited and it doesn't support right outer joins because they're just the opposite of left outer joins. So a left outer join is going to take everything from our first table that we list, and it's going to get it no matter what. And it's going to combine it with everything it can from the second table, but everything that it can't combine, it's going to leave a null value. So let's see that really quick. And we'll also try and print, we'll relabel these as call2, as call1, so we can see them both. And so you can see we get the same top, but now we have 91 rows returning. And when we get down to this point where we have people with 0 orders, and so we have customers in our database who haven't ordered yet. And so you can see that they don't have an ID in the customer table, and so it's represented by null. And when we count them, we get 0. And so we know here's all of our customers who haven't ordered, and we can see that even clearer if we throw in a where at the end here and say where o.order ID is null. And this tells us here's all of our customers who have never ordered with us, and we got 17 of them. And so that's one of the things that you can do with left outer joins. Is it's a great way to get all of the data from one table, even if it doesn't exist in another table. So I'm going to do one more complex join here for you. And so I found it weird in this database that we can't really tell how much our orders are worth. There's no order total row, header row here, and even when we look in the order details, there's no price information here, so we still don't know how much the order's worth. But we do have a product ID, and when we look in products, we actually do have a price. And so what we're going to do is join our order table to the order details table, and join our order details table to the products table so that we can get the total value of our orders. So let's do that really quick. Select all from orders, O, interjoin that on order details D, on our D.order ID equals our O.order ID, and then we're going to join that, interjoin on to our products table P on our P.product ID equals our D.product ID. And this is going to join everything up, and now we got 518 rows, which represents every line item from our order. But this is actually way too much data and not super useful, but you can see we get in one clear table, hey, we have an order ID and we have a price. And so we can actually group this by our order ID. And there's multiple order IDs, so let's specify which one. Let's just group by the order table's order ID. We'll print out O.order ID. And then we're going to need to sum the quantity that was ordered times the price. So we're going to sum our D.quantity times our details quantity times our product's price as order total. We're going to run that. And you can see now we have our 196 orders. There's 196 orders, and all of them have a total sitting next to it. Again, we got that goofy epsilon error, so we'll round this up, round that up to 2. And then we can order it by our order total in descending order. And we can see our most expensive order was for $15,353.60, and it was that order right there. So we can join this again one time further, and it doesn't matter where we do this because these are all one-to-one relationships and we don't have any left outer joins. So we can join on our customers C on our C.customer ID equals our O.customer ID. And that's going to give us all of our customers. So rather than grouping by our order, we can actually group by our C.customer name. And then we can print out our customer name. And we could call this total revenue because this would be all of our revenue that our clients have done. Oh, and we don't have an order total anymore. So let's go down to the bottom and replace that one. And this tells us that Ernst Handel is our best customer, and in their lifetime, they've done $35,000 with us. So that's kind of the power of joins. You can start to run some really cool tables. You can filter and refine this further using some of the things we learned in our first one. So we could say where our substring of our O.order date for the first 4 characters is equal to 1996. So this will tell us the revenue from 96. This will tell us the revenue from 97. And you can filter this however you want to. You could say, hey, let's only look at our customer name is like the letter A. And we have our 3 customers who start with the letter A. And you can start to filter on zip codes, by countries. On the very first examples, we saw what our country is. So rather than grouping it there, we can group it by our, let's see, let me copy this so when I click on this, it doesn't go away. We have our customers, and we have a column called country in here. So rather than grouping by name, we can group by country. And this is going to take all of the countries. Before we were dropping all the orders into the customer name bucket. Now we're going to take all the orders and drop them into our country bucket. And you can see our revenue breakdown by country. Again, very powerful, very fast, just a few changes, a few filter adjustments, and you can totally change what the meaning is of your query. And so I always try and ask myself and say in English what this query is showing us, and as I start joining my data together, I'll make sure that the results are kind of looking what I would expect them to be with the number of rows. And this means we have 21 unique countries that have done revenue with us all time because we don't have any year filters in here. So hopefully that gives you a little bit of idea on how you use joins. There aren't too many examples here of the left outer joins. We showed you one, but basically the idea is when you have something in one table that is not in the other and you want to keep the whole list intact even when there are no results, you'll start using left outer joins. So the full outer join goes both ways. Maybe there's data on both sides of the table that we want to keep, and I'll probably do that when I have dates and there's data on one side that maybe we had some come through on Monday but not on Tuesday, and on the other side we have something that came through on Tuesday but not on Monday. So both sides of the table have data that I want to look at. So they're not near as common, and I would show you an example here, but I found that they don't even support full outer joins. So when I run it, right, full outer still aren't supported on this little browser. So we'll have to get you an example of one of those later, and I'll find a real world one to do. So I'll have a few homework assignments associated with this one. that you can check out and start writing some of your own queries that help you join the tables. And again, you're always just solving real world problems. This query right here tells us how much revenue each country's done. So that is the power of joins, and you can start to group stuff together. See ya.